This video was produced in the framework of the CLIMED-FRUIT project and will allow you to discover one operational group involved in the project and the different results and testimonies that resulted from it. Starting, a little tutorial to remind you how to put YouTube subtitles in your language. First, click on the Settings button. And on the Subtitles button. You can click on the Auto-Generated Proposal. Once it is done, click again on the Subtitles button. Now choose your language. Here we are, now you are ready. Let's start with the general presentation of this operational group.
So the context we are dealing with and the issues that attract this project are the need to make this crop more sustainable, reduce the use of water, decrease carbon footprint, agroecological transition, climate change, because as we mentioned earlier, this product is nowadays starting here in the Valencian community due to climate change, but we also want to mitigate climate change by this project, and biological control. For that, the alternatives are adaptive varieties that need less water and are more adapted to our climate, a growing manual, because in this project we developed a manual because all the farmers here were more used to citrus growing and they didn't know the practices of this crop. They needed some guidance to change their habits with citrus to this different crop. And we also want by this project and by all the activities we do from the association to help to grow the Spanish avocado quality state of mind, because it could be an alternative in Europe as a product that is closer to us, and it doesn't have to spend a lot of time traveling, and it's has more quality because it's more time on the tree, and you don't lose properties of it when you harvest before it is ready. The project, the operational group Avocado Spain project was funded by the Ministry of Agriculture of Spain, and the years of implementation were from 2019 to 2021. As I sent to you, this is the web page where you can find more information about it, but we will explain it now. And if you have more doubts or you want to amplify, there you also can have access to more information about it. The objectives of the project were to implement agronomic practices and precision agriculture in avocado growing to improve sustainability of the crop and provide an alternative crop in Spanish agriculture, because, as I said, citrus was not profitable anymore for farmers because there were too many hectares of it, and also some of citrus coming to our market at the same time we have the harvesting here. Cheaper because all the conditions in other countries are different. They can use products that are not available in Spain to fight against pests, and also in social labor. Everything is different and we have to compete to it. So it was an alternative for farmers to have more profitability. And the practices that we will be presenting to you to evaluate will be the vegetable covers, some irrigation systems, and humidity probes to know exactly the water we are using to maintain the crop, and drone flights also with spectral cameras to know if we are using more water in one part of the farm or less, and make it more efficient. And we also had one practice, but we still don't have results, that we did in our experimental farm in Valencia, where we are using different varieties to see which one is most adapted to our climate conditions. Another practice that we will be presenting and evaluating is the creation of an agroclimatic map, marking the optimal zones for avocado growing, which is an interactive map where you can press on the province and see data to know if it could prosper. Because we have seen some farmers having problems with it after doing the investment, because it has to have stable temperature, as we mentioned earlier. And also the one main objective is to transfer to the sector, because we are an association for farmers and we are there to help them, and we want to transfer them all the information related to this crop. The farmers involved in the project, we were there, the Valencian Farmers Associations, the Association of Farmers that is connected to us in Malaga, and also in Cádiz, in Andalusia. The research centers were the one we have here, the public one we have here in Valencia, IDEA, the one that is public in the Canary Islands, because we also we're working in the Canary Islands, because they also have conditions to grow this crop, and it's starting to get bigger there. And also in Andalusia, the other research center we have there, La Mayora. The technology companies that were working with us were Rashid, an enterprise that sells avocado plants, and it's located in Callosa de Sarrià, in Alicante, and Syngenta, which is a phytosanitary products company, and also they sell seeds for vegetable covers, so they were convenient for this project because of that. And also Regaver, which is an irrigation system enterprise that were providing us with the material we needed for the project. As I mentioned, the geographical area of applications were the Mediterranean area of Spain and Canary Island. The location of the plots was in Castellón, Valencia, and Alicante, in the Valencian community, and also in Andalusia, Malaga, and Cádiz, and finally in Tenerife, on the Canary Islands. First, we will tell you a little bit about the methodology, but we will go deeper in the following slides. After the preparation of the project, the searching of the plots that were available to do the practices and to have information of it, we did a crop analysis related with irrigation, ground, the pests that, as I mentioned, we have the crystalline meat that affects this crop, and pollinators. For this, we developed vegetable covers and for irrigation optimization, props and drone flight. This lead to social innovation and finally dissemination through our web page and a manual for the farmers.
Now that you know more, let's see the results that came out of this project.
So, well, as we were saying, the practices, the selected practices solutions were the vegetable covers, to use the plant covers to attract pollinating insects and natural enemies to combat pests as the crystalline meat. And in addition, ground covers to save water, because it provides organic matter with its mowing, and we capture carbon from the atmosphere. So they were a convenient solution. And the second one is the capacitance probes and the drone flights that were used to determine the crop water status. And finally, the agroclimatic map that it is interactive and it has temperature data to know where the crop could proceed. the vegetable covers, we used a group of native seeds. They were selected for it, and we planted them in the pilot crops. We will put and now a video with an agronomist farmer that was involved in the project, where he explains more about these seeds and how they were planted and everything. And the advantages were soil conservation against erosion, improved biodiversity, providing a habitat for pollinating insects and natural enemies, and helps moderate soil temperature and plot microclimate, and prevent evaporation of water from the soil. We are going to put the video, right?
El proyecto GO AVOCADO Spain se ha desarrollado en España en las comunidades autónomas de Andalucía, Comunidad Valenciana e Islas Canarias, y ha sido desarrollado por entidades agrarias y centros de investigación dedicados a la investigación en agricultura. Dentro del programa operativo GO AVOCADO Spain, una de las medidas que hemos establecido para mitigar o reducir el uso del agua es la instalación de cubiertas vegetales. Con ello conseguimos una reducción alrededor del 10% del agua, conseguimos además atraer insectos polinizadores y también insectos beneficiosos para el control biológico de plagas. Dentro del proyecto realizamos la siembra de la cubierta vegetal en diciembre. Preparamos el terreno ante la previsión de lluvias y sembramos las semillas para que el riego de establecimiento se realizara con las lluvias que tenemos nosotros en el periodo invernal aquí en nuestras condiciones mediterráneas. Luego, posteriormente, en primavera, hacia abril, ya nacieron las semillas, decidimos a realizar una siega en verano para mantenimiento de la cubierta, y como especies para nuestra cubierta vegetal se eligieron una mezcla de algunas especies de crucíferas, algunas especies de gramíneas y algunas especies de plantas con flor para proveer néctar a nuestros insectos. Mediante la siega de la cubierta vegetal conseguimos un doble efecto. Por una parte, generamos un mulch para nuestro cultivo que reduce la evaporación del agua que aportamos a nuestro cultivo, y esto nos permite ahorrar en torno al 10% los aportes de agua que realizamos, y por otra estamos generando materia orgánica que, además de ayudarnos a mejorar la estructura del suelo, nos va a ayudar también a capturar carbono. Con la siembra de la cubierta vegetal conseguimos mejorar la biodiversidad en nuestro cultivo, atrayendo así insectos que nos pueden ayudar a polinizar nuestro cultivo, como pueden ser sírfidos y algunas abejas solitarias, y por otra parte nos sirven como refugio de fitoseidos que nos ayudan a depredar nuestra principal plaga, que es el ácaro cristalino. Otra práctica que engloba el proyecto GO AVOCADO Spain es la instalación de sondas de humedad del terreno que nos permiten reducir la cantidad de agua que aportamos a nuestros cultivos. La instalación de las sondas nos permite medir la humedad del terreno en continuo, lo que nos permite establecer la frecuencia y la duración máxima de los riegos para mantener nuestra humedad en la zona de exploración de nuestras raíces. Por otra parte, lo complementamos con una medición de temperatura del suelo, que también nos permite saber si tenemos o no actividad en las raíces y por tanto si podemos aplicar fertilizante o no. Y la estación va complementada con una estación meteorológica donde medimos temperatura y humedad, que también nos permite afinar con los parámetros climáticos que están afectando a nuestro cultivo. Con la instalación de las sondas de humedad del terreno también conseguimos establecer qué cantidad de agua deberíamos aportar al cultivo de manera óptima, estableciendo la duración máxima del riego para que no perder agua y por tanto fertilización, para que el agua no se nos fuera a capas profundas donde ya no hay exploración de raíces, y por otra parte la frecuencia, lo que nos permitió ahorrar en torno al 20% del agua que estamos aportando al cultivo. Con ello creemos que en unas 2 campañas puede recuperar la inversión realizada con la instalación de las sondas, que está en torno a unos 3.000 euros. Las zonas donde implementamos estas estrategias de reducir el uso del agua fueron en la Comunidad Valenciana, concretamente en Callosa de Ensarriá, en Alicante, provincia de Alicante, y por otra parte en la zona de la Charquía de Málaga, zona típica de cultivo de aguacates aquí en España. Junto a la instalación de sondas complementamos esta acción con el vuelo de drones para medir el contenido de humedad que tenían nuestros cultivos y así poder establecer una correlación entre el vuelo de dron y la humedad que teníamos disponible en el terreno, para así en un futuro poder establecer unos parámetros óptimos y poder establecer unos umbrales en un futuro para poder dar recomendaciones de riego basándonos en esta nueva tecnología.
Okay, so as Alejandro was mentioning on the video, the vegetable covers allowed us to, by using them on this project, they allowed us to save approximately 10% of the water. They reduced evaporation and they were a good option for farmers because they were not expensive. And also to maintain them, we use the insect hotels. I think you can see them on the picture. This is something we do also in our experimental farm to have more biodiversity. It's a cheap tool to have more presence of insects, and it's homemade. And they were installed in pilot plots and were quickly colonized. As also Alejandro was mentioning on the video, with this data collection of technology, drone flights, and the images provided by it, we can know the water status of the farm. The capacitance probes installed in the crops were allowing us to know the irrigation efficiency, and knowing the areas with excess or deficit of irrigation. It helped us to make appropriate decisions in each case. In this picture, you can see it, the different colors.
Okay, so the graph we are seeing is it's one of the probes we have in one of the pilot farms, and the bands have been colored according to the needs of the avocado tree. And as you can see, the soil water content of our soils, with using the information from these graphs, we can precisely fine-tune our irrigation to not apporting as much water as needed to make the full point of our soil. And in this case, you can see that too much water was used in many cases in which the soil was completely full and others was not. So this information is critical to make this not happen, basically. But we need this data to correct these problems, basically, because in most cases it's not apparent in the soil capacity to absorb water. So we need these probes, which combined with the drones gave us a more accurate picture of the water state in our soil. And the probes, an interesting point in the video was said is 3,000 euros per probe. These probes cover a large distance and really are only needed by the type of soil you have in your farm. So in an extremely large farm with different kinds of soils in different areas, you would need more than one probe. But if you know your farm is uniformous in its soil composition, you will only need one.
Also, this is convenient in the Valencia community because the farms are normally not more than 1 hectare.
Yes, our farming industry is very small plots, very small plots. So even we are looking even to use these probes not by each farmer, but by associations or irrigation groups that can all use the same information from one probe to make profitability more available to them. Because if each farmer had to put one of these, they would go out of business in less than a year, more or less.
Well, as Alejandro was mentioning also, we see the water available in different depths, and when we detect water at 75 centimeters, it means that this water is not used for the avocado. And if we do not detect sufficient water at 50 centimeters, the trees may be suffering from water stress. So this is the information we were gathering from the high humidity probes. And we are continuing to explain the other practice we selected is the Agroclimatic map. We have also a video that we will put now. This Agroclimatic map was really convenient because it allowed us to know, before doing the investment of planting avocado, to know the areas where it could prosper. And we did this agroclimatic map for the Valencian community, Malaga, Cádiz, and the Canary Islands, but it could be amplified to other areas in Europe by taking the average of the maximum and minimum temperatures provided by the network of weather stations. And this information was published, so it was easy to gather. And as I said, it could be adapted to other Mediterranean regions. So it's a map that could be amplified. You can find it in the webpage. We send you the link. And if you have problems opening it by Google Chrome, you can check in another browser, because we were checking it earlier, and I don't know why. Maybe it's because Google Chrome was not updated here in this computer. Sorry. So, as we were mentioning earlier, well, I'm going to put the video first. Yeah.
Una de las prácticas realizadas dentro del proyecto es la implementación de un campo de experimentación de variedades y patrones en la finca propiedad de Abasaja. En esta parcela experimental lo que buscamos es encontrar la variedad, la combinación de variedad y patrón que mejor se adapta a nuestras condiciones mediterráneas. Como variedades en el campo experimental tenemos la variedad Maluma, la variedad Hass, la variedad Lamb Hass, la variedad Reed, la variedad Bacon, la variedad Fuerte y la variedad Zutano. Y como patrones hemos utilizado los patrones clonales Duque 7 y Dusa, y como patrones de semilla Lula y Topa Topa. Todavía es pronto para sacar conclusiones de este campo experimental, puesto que tiene un año de edad y todavía las plantas no han mostrado si pueden o no producir frutos. También dentro del proyecto desarrollamos un mapa agroclimático donde establecíamos las zonas de cultivo óptimas de aguacate en la Comunidad Valenciana, Málaga, Cádiz e Islas Canarias. Teniendo en cuenta las temperaturas medias, máximas y mínimas proporcionadas por la red de estaciones meteorológicas propiedad de las distintas provincias, se establecieron unas zonas donde el cultivo del aguacate podía desarrollarse sin ningún problema. El objetivo de este mapa agroclimático era proporcionar a los agricultores una herramienta para tomar decisiones a la hora de establecer o no el cultivo en su parcela, ya que se han dado muchos casos en España de implantación del cultivo y luego por condiciones agroclimáticas no se ha podido desarrollar con éxito. Otra de las prácticas que realizamos fue la redacción de un manual del cultivo del aguacate, donde establecíamos todas las prácticas agronómicas para tener éxito en el cultivo, proveer a los agricultores españoles de información veraz para establecer su cultivo y llevar a cabo las prácticas agronómicas para conseguir buenas producciones. Pensamos que este manual también puede servir para agricultores de la cuenca mediterránea que quieran establecer este cultivo en sus propias condiciones.
So as in the video Alejandro was mentioning, we also had another experience because the climate in Spain, as we mentioned, is not the same as the producing areas of America. So we need to know what varieties and what rootstocks adapt better to our climate. So we are still on the process to experiment this on our farm of experiences. We are, as he mentioned, we are now testing different varieties, but they are 1 year or so old, so we still need to do research about it.
Yes, right now the main variety you see in Europe is Lamb Hass. which is a variety created as a mutation from Hass, which is the main avocado. It's everywhere. You won't see anything other than Hass, most likely in the markets. And Fuerte, it's the type B variety used in combination with Langhas for cross-pollination. And that means it's the one you would see if you were looking for a smooth avocado. You would see nowadays Fuerte. The other varieties were mentioned in the video are the ones that are being tested, which are have some merit to them, and we will see when the results are in, how they fare.
Well, as we were mentioning with the roosters, analyzing all the conditions, we will let you know in the future the results we achieve on this experimental farm we have in Valencia.